Hey, Chan Physics, just adding a video. Those of you guys who are doing this GoFormative 212 and are having trouble, I just wanted to add this video into there so that I can just tell you, watch the video. You might notice that I'm wearing my Urlacher jersey because the Bears are playing the Vikings on Sunday. And I always wear my jersey before the game, not after. So if the Bears win, you won't see me wearing one. I don't rub it in. I always put myself out there. So um, let's take a look at this. This is a classic problem that we can obviously test on. And this is one of four situations, right? We can ask if something's dropped. If it's dropped, we can ask for the velocity or the distance. So that's the first two. And then we can throw something up, and then we can only ask what's the velocity, what's the distance. And so the problems are fairly same. They have the same equations. And so let's just do this one as an example. What's the velocity of impact if we drop a penny into a wishing well and it hits bottom at 1.5 seconds? Right? Four column method. I don't know if I like green. They tell us the time is 1.5 seconds. And they tell us the initial velocity, kind of. They hide it. They tell us it's dropped. And so it says 0. All right, so remember, if they ask us for velocity, like they have here, then we have to use the velocity equation for free fall. If they ask us for the distance, then we'll use the distance equation. So not a lot of secrecy in the way that we can test this. So we write down the velocity equation for free fall, which is VF equals VI plus AT. Okay. And then if we're ready to go, right, we've got VI, we got T, we know A, because that's what we're been studying. And so the final velocity, or the velocity after that 1.5 seconds is 0 plus, and in my class, we'll always use negative 9.8 so we don't get confused on anything as we go forward. So negative 9.8 and times 1.5. All right, put that in our calculator, we'll get our answer. So the only question then is, how do we do the deepness of the well, right? The same given for this problem, but they ask us for how deep. That's a distance. So we have to use the distance equation. D equals VIT plus 1/2 AT squared. Right, that's the distance equation. And we know that we just square the time only. All right, when we plug this in, D, okay, I'm running out of room, so I don't want to confuse you. But if we put in 0 for VI, well, 0 times anything is going to be 0. So I'm just going to put in that for VIT, 0, because it's 0 times 1.5. And then we're going to add plus 1/2 times negative 9.8. Sorry about the writing. And then remember, we're going to take 1.5 and we're going to square it in just the time. Okay, I'm going to plug this in there. You guys can figure out those numbers. Remember, practice putting that in your calculator, because just because you know how to do a problem in distance learning often, right? If we put something in wrong in our calculator and we get it wrong, it's so unforgiving. And so we much rather have you guys in class where we can figure out that you knew what you were doing, you just made a calculator error. It can't be done this way. So let's be careful with our calculators. Let's make sure that for the velocity equation, we multiply negative 9.8 times 1.5, and we get that answer. And remember, we take 1 divided by 2 times negative 9.8 times 1.5, and we only square the time. Don't square the whole thing, just the time. Sorry, almost stopped that too early. Go Bears.